Hello, and welcome back to the channel. In this video, we'll be covering the definition of definite integrals and see what this representation looks like. So this will be the first time when we'll be covering this representation, and we'll cover this definition in detail by breaking down each parts of this representation. So we'll start with again the basic fundamentals of integration in order to set a plot for the representation that we'll be dealing with in the later half of the video. So when you talk about definite integrals, it is basically calculating the area under the curve when your interval is bounded. So for example, in this case, as you see on the screen, you have a curve y equals fx, and if I have to calculate the area under the curve for y equals fx bounded by those intervals x equals a to x equals b, I'm basically taking the definite integral of this function. So I'm taking the definite integral of y equals fx bounded by those intervals x equals a to x equals b, and this can also be represented in this form. So now we'll cover this representation in detail based on the already learned fundamentals that we covered in the last videos. The expression that you see over here is basically the definite integral of the function fx when your x is varying from x equals a to x equals b. So when you have to represent the area under the curve of a function which is bounded by two integrals, you basically write the whole expression in this form, where fx is basically the function you're taking the area under the curve for. After the function, you either have dx or dy in this expression, and this gives you an idea about where your endpoints are located. So if it's dx, your endpoints are located on the x-axis. If it's dy, your endpoints are located on the y-axis. So depending on dx or dy, you judge where your endpoints are located. And on the left hand side of the expression, you basically see this integral sign. This is basically the representation of integration, or when you have to calculate the area under the curve. So you have this sign, and the values that you see on the lower hand side and the upper hand side of this integral sign are basically your endpoints. The value which is located on the lower hand side of the integral sign is basically your left endpoint, and the value which is located above the integral sign is your right endpoint. So if I have to sum this expression up, I basically am calculating the area under the curve for the function fx, where my x is varying from x equals a to x equals b. And this is basically the same thing as the area of this shaded region represented on the screen. But before wrapping up this video, we'll cover another example just to reinforce the idea of definite integrals. So as you would know as well, in the last video we covered that the area of the function e to the power x bounded by the values x equals 0 to x equals 1 was calculated to be e minus 1. And based on this information, we'll try to write the definite integral of this function, or represent the area under the curve for e to the power x as a definite integral. You can pause the video right now and solve by yourself and can confirm your answer at the end. But before writing the actual answer, I'll first write the prototype of how my definite integral should look like. So my definite integral should look somewhat like the definite integral which is bounded by the values a to b for my function fx dx. And in this example, since my function is e to the power x and I'm varying my x values from 0 to 1, I'll basically write dx where my intervals are bounded by x equals 0 to x equals 1, which can also be simplified to integral 0 to 1 e to the power x dx. And this is exactly the area under the curve for e to the power x bounded by the intervals x equals 0 to x equals 1. And we also calculated the answer of this expression in the previous video, which came out to be e minus 1. So to sum everything up, I'll write the final result, which would be integral 0 to 1 e to the power x dx equals e minus 1. And this is the final answer, or the actual area under the curve for e to the power x, which is finally represented by the definite integrals. So that was it for today's video. I hope you found this video interesting. Follow the channel in order to get notified about the other videos as well. Thank you so much for watching. Bye bye. Stay tuned.